Hello everybody. Today we are going to be doing what we call the candle lab. The candle lab is all about making qualitative observations. Qualitative observations on how a candle burns. Have you ever thought about how a candle burns? That's what we investigate in this lab. But our investigations are all going to be qualitative. In class, you should have learned the difference between a qualitative and a quantitative observation. In this lab, all of our observations are going to be qualitative, meaning we're not really going to be measuring anything or working with any kind of numbers. And it's all going to be about how a candle burns. Okay, first up is to examine the candle and look at it, describe it. It is smooth, it is kind of cylinder in shape, except for the top part where the wick is. It is odorless, it is a solid, and it's waxy. I have a glass square that I'm going to set on the lab counter, and I'm going to take our candle and I'm going to heat the bottom of the candle and secure it to the glass square. So I'll light a match and add some heat to the bottom of the candle. That'll soften up the wax a little bit, just like that, and secure it to the glass square. Now I'll take a second match and I'm going to light the candle. And we're going to watch it burn for a few minutes here. And you want to describe the way the candle is burning. We could see the flame is giving off light. It's wafting back and forth a little bit. If you were close enough, you could feel some heat being given off by the flame. And I could see some wax melting, going from the solid to the liquid phase, and dripping down the side of the candle. It has been about 15 minutes since we lit the candle, and notice the difference that we have here. The candle is significantly smaller because a lot of that wax has burned. It has burned away. Some of it has dripped down here on the side. As you can see, it's still dripping. But the big thing is the candle is significantly smaller. Okay, my next step is I'm going to take a lit match and I'm going to hold a lit match up to the candle. But before I do that, I'm going to blow the candle out. And quickly, I'm going to hold the match up to the candle flame because I'm concerned about what is actually going on here, and is it just the stuff we could see, or potentially is something else going on here that maybe we can't see? So let's watch closely. Let's try that again. I now have a micro slide and a micro spatula. And what I'm going to do is transfer some wax from the bowl of the candle, the bowl of the lit candle, onto the micro slide. Like that. Now, will that wax burn like it burned with the candle? Well, let's try it out. So I'm going to take a match and I'm going to try to just light the wax. doesn't seem like it wants to burn. Okay, in the first step of the lab, we examined the candle, and part of the candle was the wick, which is made out of string. Is it possible the wick could be made out of something else, like say wood? Why don't we try a toothpick? So I have a toothpick here, and I'm gonna go to the candle and blow it out, and I'm gonna insert this toothpick next to the wick into the candle. And why don't we light that and see if we could use a toothpick as a wick instead of string. Seems like the toothpick doesn't really want to burn. It's kind of going out. So why don't I try to relight it now that it's closer to the wax. Now we see the toothpick has relit the candle wick, but the toothpick itself is not maintaining a flame. So a toothpick probably isn't a good thing to use as a wick. Why couldn't wood be used as a wick? Why would this not make a good wick? Wood, as opposed to string. Okay, so we don't think wood makes a good wick. We believe we want it to be made out of string. So could I just burn a piece of string? Would that work as a candle? String by itself. Well, let's try it and see. I lit the string, but you could see it kind of wants to go out. I'll try lighting it again. Seems like it's burning a little bit, but then it kind of goes out. It can't maintain the flame like when the candle was burning. Now it seems like I can't light it at all. There we go. And it goes out again. So string by itself, would that make a good candle? Okay, so the string doesn't appear to make a good candle by itself. So let's see if we gotta have multiple things combined together. So with this step, I'm gonna take a little square of aluminum foil and a pair of scissors, and I'm gonna make a little slit into the aluminum foil, about to the middle of it, like that. Now I'm gonna take this square of aluminum foil that has the slit in it, and I'm gonna create a barrier between the wick, which is a piece of string, and the wax. Okay, I have my aluminum foil with the slit cut into it, and I am going to wrap it around the candle to create a barrier between the wax and the wick. And you could see what happens when we separate the wax from the burning candle wick part. Next step we're going to test a product of the burning candle. And to do that, we're going to use this test paper that is called cobalt chloride paper. Cobalt chloride paper is used to test the presence of water. Cobalt chloride paper is blue, and when it comes in contact with water, it's going to turn a very light pink, almost whitish color. And let's see how we're going to use this with the candle. Now I have a beaker, and we have our burning candle. I'm going to take the beaker and turn it upside down and hold it over top of the candle. While I do this, I don't want the candle to go out. I want it to continue to burn for probably at least maybe 15 to 20 seconds. And I'm looking for something to collect on the side of the beaker. Due to the fact that candles don't burn perfectly, you may notice some black soot forming on the top of the beaker, but that's not what I'm looking for. I'm looking more for like something that will resemble condensation on the side of the beaker. Okay, so we have collected some material on the side of the beaker. Now I'm going to test it with the cobalt chloride paper. So I could turn the beaker over, and I'm going to take this cobalt chloride paper and wipe it on that material. And again, we are looking for a color change from the cobalt chloride paper, which was blue, to this almost whitish pinkish color. Okay, this is the cobalt chloride paper before. Notice it's blue. This is the cobalt chloride paper after. Whitish, pinkish. The next step involves us using another indicator that is called lime water. Lime water is not water from a lime. It is a saturated solution of calcium hydroxide, and it is a very good indicator of the presence of carbon dioxide, which we're going to be testing for next. The lime water is clear. It's a clear solution, but when it comes in contact with carbon dioxide, it forms a precipitate. And a precipitate is a solid that forms in a chemical reaction. So this clear lime water, we're going to look for it to turn a cloudy color. So next, I have measured out approximately 10 milliliters of lime water. Now remember, our lab is a qualitative lab, not quantitative, but this is the one step where I actually did have to measure something, but it doesn't have to be real exact. I actually do have a little over 10 milliliters of lime water, but that's not going to hurt anything. Our focus again is qualitative observations. Now I have an Erlenmeyer flask. And what I'm going to do is I'm going to take the Erlenmeyer flask and I'm going to hold it over top of the burning candle, kind of like what I did with the beaker in the last step, for say about 30 seconds. And again, I'm just collecting some material from the burning candle into the flask. And I could clearly see it is collecting inside of the flask. And what I'm going to do here in about say 10 to 15 seconds is turn this flask over. I'm going to pour that clear lime water into the flask. I'm going to stopper it and I'm going to shake it, and I'm going to look for a change in the lime water. So I'll turn this over, set it down. I'm going to add the lime water, and again, notice the lime water is clear. I'm going to pour a stopper, put a stopper onto the flask, and I'm going to give it a good shake. And you should clearly be able to see there is a change in the lime water. The lime water has turned cloudy.